Good morning all. Here's an Homag input card, and the complaint is that input D does not state change on the processor, but the LED turns on and off. So we are going to go through and test all of these components, and at the end of the video I'll show you my drawings that I've got of this circuit. Now I've only mapped out one channel. You don't need to map out all of the channels, because once you get one mapped out, they're all the same. I got my meter set to diode mode, and the first thing we're going to look at is the input side of these opto-couplers. Now the inputs are driven through this circuitry on this connector right here. Let's turn the light on and see how that looks. There you go. Alright, now pin 1 is the anode of the input LED inside this CNY17 opto-coupler. Pin 2 is the cathode side. There we have a diode drop of 1.066. Next opto-coupler, diode drop of 1.054 volt. Now let's go to this opto-coupler and look at that. That opto-coupler is open. Let's go to the fourth one. Oh, get on there. Slipping off of that one. Alright, there we go. 1.047 volt diode drop. 1.050 diode drop on the fifth one, the 6 opto-coupler. 1.058 volt. 1.051. 1.051, 1.053, 1.060, 1.052, 1.057, 1.052, almost at the end. 1.052, 1.052, and the last opto-coupler, pins 1 with the red lead on the anode, pin 2 with the black lead on the cathode, 1.052 volt diode drop. That is good. Now let's go through and let's check the LEDs, the resistors, and the diodes in this circuit. Let's try the LEDs first. This is the F LED, 1.538, and the LED is illuminated. Here's E LED, 1.529, the LED is illuminated. Here's D. That LED is good, it's illuminated. We have a diode drop of 1.534. C LED, 1.531. B LED, 1.519. A LED, 1.540. 9 LED, 1.530. 8 LED, 1.50, 1.550, 7 LED, 1.540, D LED, 1.547, 5 LED, 1.512, 4 LED, 1.539, 3, 1.520, 2, 1.543, 1, 1.532, and the 0 LED, 1.511. Now we're going to check the resistors and Zener diodes in this row. Okay, the Zener diodes and 3.3 kilo-ohm resistors are good. Let's check these diodes and resistors. These are 1 kilo-ohm resistors. That's good. Okay, the 1 kilo-ohm resistors are good. Let's check the 1M4007 diodes. Nice. Now everything is good on the input side of those optocouplers except for this one optocoupler right here. The solder sucker never removes all the solder from the vias of the circuit board, so I use solder wick to wick out that solder that the solder sucker never removed. Now I push the pins of the optocoupler away from the walls of the via. That way I don't rip out any traces when I go to remove that optocoupler. Look at that. The optocoupler fell off the circuit board. I must have did a good job. Okay. I got a little pin straightener for ICs right here. I'm straightening out the new optocoupler's pins so that it'll sit down into the vias of the circuit board. I want to, before I solder the new optocoupler on the board, I want to make sure it's okay, so I test the LED input side and the NPN transistor output side with my DMM set to diode voltage test. That's a good optocoupler. Now I hold the optocoupler with my ring finger. This gets a little tricky now. And then with my index finger and thumb, I hold the soldering iron and then solder that optocoupler onto the board. I wished I had 4 hands to do this job sometimes, but I don't. So you improvise. There we go. Get denatured alcohol, and we're going to clean up our work. Now the optocoupler has been installed. It's time to perform the test on our repair. And we're going to test all of the optocoupler inputs, viewing all the optocoupler outputs. This part right here gets a little bit tricky and you got to be careful. you have on the optocoupler input side 24 volts DC. And on the optocoupler output side, the NPN transistor output side of the optocoupler, driving into the logic of that Homag input card, you have plus 5 volts DC. You can't get these mixed up. You can't put 24 volt on the 5 volt side, and you can't put 5 volts on the input side. You put 24 volts across those CMOS ICs, and you'll be replacing all of those integrated circuits, so be careful here. Be very careful here. You'll see in the next couple of minutes that I double and triple check my external DC power supplies attached to these cords. I don't want to be doing more work than I don't want to be doing more work than I need to. Life's already hard enough, much less when I screw up and tear things up on my own. Okay. Y'all know how that goes. I'm sure y'all have been there once or twice. Now here, you don't want to get distracted. You run everybody else out of the room when you're hooking these things up right here. Don't have those farm animals button up against your kneecaps or nothing like that. You run the farm animals out of the building. You run the people out of the building because you don't want to put 24 volts DC on the 5 volt logic side of this board. You have to have total concentration at this point right here. Here's the double check. I want to make sure that plus 5 volts DC from that external power supply is going to VCC of the CMOS ICs on that board. And here we are checking to make sure that the ground of that 5 volt DC power supply is connected to that external power supply. And here we're good. Now when I apply power to that circuit, I place the oscilloscope probe on VCC of the logic ICs and turn on that power supply. And if things are good, it should go to plus 5 volt DC on the oscilloscope and not negative 5 volt DC. Here's the 24 volts that we're applying to the input side. I'm going to use a pick tool to probe the inputs. And as I probe the inputs, as I pull the inputs to that 24 volt DC ground, the outputs will go low on the output side of the opto-coupler. It'll go from +5 to ground. There we go. You can see on the oscilloscope that the inputs go from +5 to ground. I really love working on these circuits because you could test all of the inputs and all of the outputs of this circuit. It's a very nice circuit to work on. You can see the logic state change from high to low on the oscilloscope. We're looking at the collector of the opto-coupler. It's amazing that you are able to test these circuits outside the machine. This is probably how they do it at the factory when they manufacture these cords. They got some poor soul like me out there with the probe to ground on the 24 volt DC side and oscilloscope, looking at the output of the opto-coupler. Oh, there you go. Now, what we're going to do, we're going to move the card around and we'll look at the LEDs. We'll look at the LEDs turning off and on when I probe those optocoupler inputs. Now we're kind of way up in the air, but you'll see it. You'll see it. Here we go. We're going to probe the input. Can you see that LED state change? We're kind of far off, but we can see it. Almost at the end. There's the last one. Now we're going to go through all of them, back to LED 0. That's it. Everything is good. And the only bad thing we found in that circuit was the D-opto-coupler input had failed. It had opened up. Let's unhook everything. And when I get to the house, I'll put my drawings up and we'll talk about them. Thank you, folks, for stopping by. Thank you very much for being here. I always appreciate it when you come over. See what we're working on next. Even though here we're at the house, we're going to talk about the Homag input card. Now real quick, take a screenshot of this music right here and go out and learn that on your fiddle. You'll really enjoy learning that on your fiddle. How does it go? Okay. Enough of that. Can I put this in the way real quick? We got to go to work. Here is one input channel on that Homag input card. We're going to get closer to this in just a second, and we'll discuss how this works. Give me a second to get closer. Here we go. We're a hair bit closer. We have a Euro connector, P1, whose 18Z through 32Z we apply plus 24 volts DC from an external power supply. That plus 24 volts DC is applied to the LEDs. Now this is common between all of the LED inputs. So let me draw that out there. It goes to all of the anodes of those inputs. We have plus 24 volts DC up here on the anode of that LED on the front panel. We have a 3.3 kilo-ohm current limiting resistor to the anode of a 1M4007 diode. The cathode of the 1M4007 diode goes to the 1 kilo-ohm resistor back to this input right here, 28D, that we pulled to ground of the 24 volt DC external power supply. So plus 24 volts up here, and you don't have to apply it to all these pins. I put it on 32Z. And grounded with the probe on 28D. That illuminated this red LED on the front panel. Now branching off, we have two paths for current to flow. First, from 32Z plus 24 volts, the current flows through the red LED on the front panel, through the 3.3 kilo-ohm resistor, through the forward biased 1M4007 diode, the 1 kilo-ohm resistor, back to ground that I probed to ground. That's one path. The second path is through this 7.5 volt Zener diode. And that, when we put 24 volts up here and ground down here, we have, if you were to put your voltmeter across this diode, you'd measure about 7.5 volts DC. Current flows through that Zener diode, through the anode of the LED inside the CNY 17 Opto-Coupler, through the cathode, back to probe ground through the forward biased 1M4007 diode and the 1 kilo-ohm resistor back to ground of the 24 volt DC power supply. So we have current flow through here and current flow through here. Now when current flows through the LED of the CMY17 opto-coupler, photons are emitted into the base of the phototransistor, causing it to go into conduction. And we saw in the video that we were at high on the collector, and then when we turned on the input, the output went low. Nice. Very nice circuit. Let's put up the next page and we'll look at all of the inputs. Alright, are we close enough to see this page? I hope so. On Euro P1 connector, we apply plus 24 volts DC in from an external power supply to connectors 18Z through 32Z. Now you don't have to connect all these pins to plus 24 because they're joined together on the board. I applied that plus 24 volt DC to 32Z. Over here on the Euro P2 connector, this is the logic side, this is the input side, this is the logic side. I placed plus 5 volt DC in on pins 1A and 1C and ground of that 5 volt DC external power supply to 2A and 2C. Only one of these is required, again, because they're joined together. 1A is connected to 1C for the plus 5 volt DC in, and 2A and 2C is connected together for the ground input. These connections right here, I pulled to the plus 24 volt DC ground of that external power supply. Input 0 through input F. Input 0 is on 2D. I probe 2D with the ground of that plus 24 volt DC to activate that input. 4D, 6D, 8D, 10D, 12D, 14D, 16D, 18D, 20D, 22D, 24D, 26D, 28D, 30D, and 32D to activate 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, F, E, F inputs. Nice. Isn't that amazing? That is amazing. Alright folks, if you want to stick around a little bit, let me set this down here. If you want to stick around a little bit, I'm going to cook me some yellow potatoes. I got me some little yellow potatoes sitting down there in the bucket. I'm going to put them in some hot water because y'all know us McDonald's, we love our potatoes. Okay. Alright. Alright, I hope this helps you to troubleshoot, repair your Homag input cord. We'll see you when the sun comes up.